our guest speaker, Professor Brioni Moore. Brioni is a distinguished biomedical researcher, an academic teacher in infectious diseases pharmacology at the Curtin University. I need to inform you all, excuse me, Curtin University has improved dramatically since I finished my pharmacy course in 1965. That's right, 60 years ago. There was then Bentley tape on the door. So
that's one building, wasn't it?
Yeah, one concrete bunker to house the students. So, Brioni's research focuses on infectious diseases, particularly malaria, in low-resource settings like Papua New Guinea. As a recent recipient of the prestigious Bill and Melinda Gates Foundation, this is a good one, Global Grand Challenge Grant, and multiple National Health and Medical Research Council of Australia grants, her research informs policies of World Health Organisation and shapes evidence-based practice to improve clinical, management and treatments of malaria in pregnant and postpartum women and their babies. Brioni is an active advisor to the World Health Organisation. Brioni is also part of the Curtin Medical School and the Curtin Medical Research Institute and leads the Advanced Biomedical Sciences Honours degree. She holds an honorary fellow position at the Kids Research Institute Australia and Papua New Guinea Institute of Medical Research. While most of her recent research activities involve clinical trials of PNG, Brioni has a significant laboratory experience for preclinical model of malaria infection. In addition to her research, Brioni is an active member of several organisations. She also collaborates with international partners such as Medicines for Malaria Venture, Asia Pacific Malaria, Elimination Network, and the Rollback Malaria Partnership to advance global health initiatives. In her limited spare time, Brioni has a passion for cooking, spending time in her garden and long nature walks with her beloved cocker spaniel called Lucky. So, please welcome Brioni as we discuss our anti-malarial trials for K. senegalensis. It is supported by the Rotary Club of Perth, as you've heard, and Curtin University. And you might be aware that District Governor Pat is here, and we're not angling very much for the foundation to contribute, but we're hoping that the foundation will get the message and we record it for them. As we all know, Rotary is one of those institutions. You've got to go slowly, but definitely tick the box and you'll get there. So, just on a serious note, a child dies every 2 minutes in this world. So, Brioni's work has never been more important for Brioni.
Thank you very much, Jeff, for that incredibly generous, kind introduction. I don't know if I deserve it all. Wesley, for the invitation to be here today, and for you all to be here as an audience for me to present some of the work that I've been doing along with students in our laboratory at Curtin University. Before I start, now I'm a bit of a storyteller, and please make sure you keep me to time because I do tend to go off on tangents. But on my walk with Claude this morning, as we were watching the sunrise, I was reflecting on my relationship and journey with Rotary, which has spanned now 17 years. And in fact, the last presentation I gave to a Rotary Club, which was Rotary Fremantle, was after I'd received an award from the Fremantle Medical Research Foundation, which was sponsored by Rotary Fremantle, and it was the first scientific presentation I gave as a newly graduated PhD student. And I was embarking on a career as an independent researcher. Now, the reason I mention this is that small study that was done where we looked at the potential to modify a treatment regimen for children in a drug called Primaquine from 14 days to 3.5 days, received $5 million grant this year to implement in 5 different countries to look at the efficacy for treatment of vaccine malaria in children. Okay. So it just shows that these small seeds at the start have such a massive impact in people's journeys. And not only that, the award went towards my own professional development. It gave me confidence as a new leader within the research scope. It gave me a great track record on a CV that I've continued to build upon. But that investment was not only in a research project, but was in a person. So I'm incredibly thankful for Rotary for starting that journey for me. As mentioned in my introduction, I have a very long and passionate, enduring relationship with Papua New Guinea. I lived there for 6 years. And again, Rotary has played a really important role in Rotarians for Malaria, in funding BEGNET initiatives for rolling out anti-malarial drugs, for making sure people have access to safe, clean water, for providing opportunity for education. So Rotary definitely has a very dear place in my heart, and it's a real privilege to be here today presenting work on our investigations of this potential new anti-malarial candidate. So before I go any further, I would like to acknowledge that we have the privilege today of meeting on Wujak Noongar Budja, and I pay my respects to elders past and present. I acknowledge that Aboriginal Australian and Torres Strait Islanders were our first research scientists in Australia, our knowledge holders, and I have a long and enduring respect and desire to continue to learn alongside First Nations people in improving health and medical research for all. So today, as I said, I have the honour of standing before you to present an overview of some research that was conducted last year. But full credit goes to the person on the screen here, Mr. Sergio Lospa, who was my honours student for last year, and he was a student enrolled in the Bachelor of Advanced Biomedical Science honours course in Curtin Medical School, and that is the course that I also have the privilege of overseeing. Now, this body of work, which, as you'll find as the story evolves, didn't quite go to plan, still earned Sergio a first-class honours as part of his graduation. And unfortunately, he can't be here with us today because he has a full day of medical training as he was accepted into the UWA medical program this year, which has been a long, enduring journey for him. So again, this training opportunity that he has received through the generous sponsorship has enabled him to grow his wings and expand into a path that will eventually be a very rewarding and generous career. Okay, so let's get into the nitty-gritty of it all, malaria. Now, I'm not sure how many people are familiar with malaria, if any of you have had malaria, but I think the main points that we need to take away from this is that it is a tropical infectious disease. And we have 3 critical components that are required for somebody to get malaria. We need a mosquito vector who has infective parasite forms within its body. We need a suitable host, so for the disease malaria, we need humans, and we also need an environment that enables the development of this parasite and disease status. Now, we've got over 200 different species of these plasmodium parasites. Thankfully, only 5 of them are able to cause human disease. We hear about falciparum malaria the most because this has the capacity to develop these, what we call like sticky fingers, that allows it to attach itself to the lining of our veins, our arteries, our capillaries, and stop getting cleared from the body. But it can also transfer over the blood-brain barrier and cause a disease we call cerebral malaria, which is responsible for 98% of deaths that we have associated with the disease. So it is very much known as the notorious form of malaria. However, we've got a secondary form, vivax, which is actually the most widely distributed species. So over 2.5 billion people at any time are vulnerable to obtaining vivax malaria. And it will cause this chronic disease that, whilst it may not kill you straight away, you will have a lifetime of anemia, of fatigue, which can lead into severe morbidities at the end. So it is a really nasty infection. And what makes it even more of an issue for us is it has this ability to form dormant parasites. They hide away in our liver. And these parasites can emerge at any time that you become a bit run down and immunosuppressed. And we really began to learn more about vivax malaria after wars such as the Pacific War, Vietnam, where returned soldiers came back to Australia and kept getting malaria infections, even though we don't have the mosquitoes and we don't have the parasites native here. And this is when we really learned about these hidden parasite forms. The problem is these parasite forms are really hard to treat. And this really brings us into the theme of what we are trying to do here, and that is better understand what anti-malarial drugs we have available and how we can make them better. So just looking at our heat map, as you can see, we obviously have our tropical, subtropical areas of the globe, closely aligning with low and middle income countries that are highly susceptible to malaria disease. The WHO reported 263 million cases in 2023, about 600,000 deaths. The reality is, in most of these countries, health reporting systems are incredibly poor, which means we're probably only looking at the tip of the iceberg here. But still, we're looking at significant numbers of people. Despite 50, 60 years of sustained efforts in trying to eradicate malaria, we potentially can look at it and say, well, are we actually that much further forward in the agenda here? We're still having massive morbidity and mortality, and even though we have these strategic goals to eradicate malaria by 2030, we still have 83 countries in 2025 that have malaria endemic, although we have eliminated in 26 countries. So obviously the quest goes on. What I would like to highlight here is, as we can see, Papua New Guinea and West New Guinea, directly above Australia, has some of the highest incidence of malaria that we have in the globe, or at least related mortality and morbidity per capita, and yet they're our closest neighbour. Okay, so this is one of the reasons why my research has very much been focused in this country. Don't worry, I'm not going to bore you through the life cycle. It is just to highlight that we have these different components. We have the mosquito phase over on our left-hand side, and then once the infected forms go into the human body, we have a liver stage where the parasites develop for 2 to 3 weeks and then emerge in a blood stage infection, which is where you start to see the symptoms. The reason I highlight this is it moves us on to when we're starting to actually look at drug targets. And as we can see in the boxes along the bottom, this is showing how we have specific drugs that target different stages of the parasite life cycle. One of the increasing problems we have towards malaria elimination is those that I've highlighted in red are those drugs that we now have parasite drug resistance, which means that in many countries, these drugs are no longer effective. So I think, as we can very clearly see, we are seeing a very quickly diminishing pool of drugs that are available for effective treatment. And therefore, how can we look forward to global elimination goals if we don't have the resources to support our endeavours? But do not fear. We do have hope in progress, and this lovely colourful chart was put out by the Medicines for Malaria venture. But I really wanted to put it forward to demonstrate to you all the pipeline that we must consider when we're looking at new drug therapies and the time that is associated with it. So as we move from left to right, on the left-hand side, we're looking at drugs that are newly conceptualised. We're looking and thinking, do these have any activity? And so we put them through preclinical screening, like what I will describe in a moment. Then, as we gather evidence, we move across the product pipeline until finally we hit the purple area, which is where the drug becomes accessible to the general broad populations. And then we look at the timelines. So, in general, it will take 5 to 10 years for a drug to get through our preclinical early investigations, and then a further 10 to 15 years to hit the product market. So we're not talking about a quick journey here. However, we do have opportunity for repurposing drugs that are currently available in markets that already have safety profiles that might be supported by the FDA or the TGA, and that may help us fast track some of these transition pipelines. So one thing our research group does is go out and search for treatments that we feel that might have the opportunity for some optimisation to make them more targeted and effective. This could be changing the treatment duration we give them, or how frequently we give the drug. Maybe the drug needs to go with a different partner, or maybe we start to look outside into the big picture, into other available opportunities. And that brings me to the focus of the presentation today, which is looking at K. senegalensis as a potential antimalarial candidate. Now, as it was mentioned in the introduction, our interest in K. senegalensis really started when Jeff and Rick made contact to say, we've got this potential product, what do you think? And looking into it, we discovered that it's a tree that's native throughout Africa, particularly West Africa, and it is commonly used for traditional medicine. So traditional healers will often brew teas of the leaves, of the bark, of the seeds, and then use this to treat a variety of different ailments. This ranges from headache and fever, but I guess more importantly in this situation is that it is known as African quinine. And as you may all know, quinine is perhaps one of the most potent antimalarial drugs that has ever been available. It is found from tree bark, again, from a South American tree, and still maintains an important role in antimalarial therapy today, as many native products do. So this piqued our interest. We've got this traditional healing medicine is used for antimalarial therapy, so what do we need to know more about it? Of increasing interest was the fact that Rick disclosed, well, in 2014, the Therapeutic Good Association in Australia has approved its ranking as a medicinal plant. So here we've got a potential colloquially known antimalarial drug that has TGA approval to use as a medicinal product. So maybe we should start to look a little bit further. So what do we actually know about this? So the first thing that any student of mine will do is go into literature. And I make them search the databases to see, well, what has been published? And this is what Sergio had to do for the first part of his honours. And actually we came up with very little published material. What we did know was that K. senegalensis has been extracted in a variety of different solvents, so water, and then it's an alcohol basis, so methanol and ethanol. And we had 10 published studies. And these were all from West African countries, and the methodology was quite diverse and potentially lacking in detail. So it was quite difficult to get a bit of a grip around what the actual scenario was. We did know that in vitro assessment of a bark extract showed the strongest antimalarial performance compared to these ethanolic and water extractions. So that really honed us in, okay, we need a methanolic extract here to further investigate. We found one study that had evaluated this methanolic extract in mice. They administered it through intraperitoneal injection. So this is where we inject into the abdominal cavity of the mouse. The reason we do this is it is a nice open space that allows quick absorption of the drug, so therefore we're going to see the effects quite quickly when we're looking at a safety or a pharmacokinetic perspective. This group reported that it was very safe, so a toxicity or lethal dose greater than 5,000 milligrams per kilogram is quite high in relation to other drugs. However, there was little safety data available. So obviously this is where we really needed to start our investigations in animal models. As I did allude to before, the published findings were highly variable, which meant that if we really want to progress this pathway, we really have to generate some robust data that we can say this has scientific integrity and we're very happy to build a further research program around it. So in collaboration with Bioactive Laboratories and Griffith University, they had this product which was developed as a methanolic bark extract, and I'm going to refer to it here as KSME1 for the remainder of the presentation, because obviously saying K. senegalensis every time is a bit of a mouthful. But you can see in the picture here, this is a photograph Sergio took of the raw methanolic extract on the bench. It's quite a powdery substance, quite a solid form, which was quite unexpected. I must admit, when I first looked at it when it arrived in the laboratory, I thought, oh, how are we going to put that into a nice stable suspension for injection? Which obviously was going to be one of our challenges. And so they came to us with the need and the desire to investigate this compound in preclinical malaria models outside a culture system. So let's start looking at a biological model where we can consider factors like the immune system, liver metabolisms, and all these other aspects which are integral for furthering a drug development. So we all sat down, put together some lovely lofty aims where we were going to evaluate the safety and tolerability of our compound in healthy and malaria-infected mice. We were then going to evaluate the malaria treatment efficacy of both using it for treatment and also prophylaxis. And this is the application we put forward to the ethics committee. Now, from this point on, I'm going to tell you this constantly evolving story of research that happened, which, like all good research, never goes to plan. But we still get a really good story out of it, and Sergio has contributed some really important data that will inform how we move forward. So the first thing that happened was animal ethics approval was granted. However, we did have some very strong caveats. And there was some concern of the lack of data that was already available in the published literature. So our first caveat was we have to demonstrate safety and tolerability using the healthy mice with intraperitoneal injection to replicate what's already been done, and that we have to have the vets supervising everything we do to make sure that welfare is maintained. So we said, okay, we'll go forward like that. So the first thing Serge did was he created a formulation. Now, the published literature said we pop our crude extract into water, give it a good shake, and then inject it into the animal to further investigate. As you can see by the extract that was put into water, we had quite a lot of particulate material in there. And if you let it sitting on the bench for a couple of hours, it separated very nicely into aqueous and substrate sections, which is not ideal. So we decided to do a level of filtration so that we could try and get rid of some of the bulky components to try and make it a nicer treatment experience for the animals. Unfortunately, it didn't bode very well, and it caused a bit of cramping in the mice, which of course, as we're being under strict animal ethics control, the project was halted momentarily while we further investigated this. And really the outcome was, we've got no concerns for toxicity here, but it's causing some discomfort, and it's probably your formulation. And we agreed. So we went back to formulation science and changed our aims a little bit to say, all right, let's redevelop this formulation, and then we'll test it forward. So instead of doing an anti-malarial efficacy project, Sergio got to experience a bit of pharmaceutical science. And he went aside and started looking at different solvents to try and get a better injectable formulation for our project. DMSO was found to be the best solvent. The problem is we're only allowed to inject concentrations of 10% or less into animals without causing toxicity issues. And as you can probably see from the vials, at 10% we're not really getting good dissolution of the substrate as it is. But still, the vets were happy, we went on. Again, we had a little bit of discomfort in the mice, and the project halted again. So where do we go from here? Well, we put our foot down and said intraperitoneal injection is not a reliable way of administering this drug. The published findings, we're not sure what they've done, but we can't correlate this information. We need to give an oral administration as you would if you were taking the medication yourself. So we got approval to move forward along this line and then obviously further investigate. So Sergio then went forward into the world of pharmaceuticals and all the different formulations for oral administration that one can do to make sure we have a good pH balance, to make sure it tastes okay, because obviously now we're giving it via mouth. We have to make sure that the mouse will actually retain the formulation, and a whole other factors to make sure that we get a really nice suspension, because we don't need to dissolve it anymore, that isn't going to cause any substantial issues. And we went through a varying number of formulations until we landed on one that we thought looked very nice. It had great stability. We could sit it on the bench for 7 days. We didn't have any separation. I must admit we didn't taste it ourselves, but we thought that the components in there wouldn't be too distasteful, and so we proceeded along this line with this oral formulation. I am very pleased to say that we were able to administer our multi-doses, and it was very well tolerated by all of the animals with no issues whatsoever, no cramping. The mice just jumped back and went back to their normal daily routine straight after dosing. And we had no adverse events reported through the entire protocol, which was fantastic news. As part of this, we also wanted to look at key parameters that would detect whether or not we were seeing any effect on important metabolizing organs and extraction, so the liver and renal systems, as well as the blood hematology. Very pleasingly, we saw that there was no significant difference in the groups for biochemistry parameters across the board. So our control group with 0 had no difference to our highest dose, which was 500 milligrams per kilogram. And we can show, this is some of our preliminary data here. You can see we've got our different groups in the graph here for ALT. We've got our 0 control on the left, and then we had 100, 200, and 500 milligram per kilogram dose groups. So what we have observed here is that we do have a trend for increasing levels of ALT, so a liver enzyme, in our high dose groups, which could be an indicator for liver stress or inflammation. Now, we don't have enough information. We're looking at sample sizes of 10 here for our mice, so it's very small. And they are still within normal parameters for the mice. So we're not concerned, but we do need to keep an eye on this trend. We did, however, see a significant increase in the platelet count, as you can see here in our high dose group, which could be an indicator of inflammation. Now again, we need to investigate this further. So where do we go from here? Well, our short-term goals this year is to confirm the safety and tolerability now in malaria-infected mice. I had an honours student lined up to continue this work. Fortunately for the student, unfortunately for me, they were also admitted into a medical program, and so I have lost that student, but we do have some support coming through the team to get this work completed this year so that we can actually look at some of this anti-malarial efficacy work. Once we've confirmed the safety, we will then move forward to looking at both prevention and treatment. And the idea here is we gave 5 doses for our safety study, which is probably 3 doses more than we would intend in a normal treatment pattern. So there are very promising signs here. What does this look like in the future? Well, I think we all get a little bit excited when we see the potential for future directions in a landscape that is lacking future candidates. And the in vitro work for K. senegalensis is definitely promising, and I really am looking forward to hopefully being able to report that we see these same results in our animals. So the first thing that we would want to do is look at pharmaco-investigations to understand how the drug works. This would start in animal models and then move forward to human models. And then we would look at designing and investigating varying combination therapies in these preclinical models. Now, again, if we consider our timelines, we're talking durations here, but it really does depend on the progress and the results that we obtain. So not making any promises, but I do remain optimistic. And finally, I would just like to make mention of a few of the many people who contribute to this research. Sergio, who worked tirelessly through his project, both in formulation science and animal work, to generate our data. Our research team, as well as the veterinarians who were involved. Bioactive Laboratories, who provided the drug for us to investigate and for the collaboration. Anthony Carroll over at Curtin University, who has provided the methanolic extract, but of course Perth Rotary and Jeff Leach for actually making that initial connection. We value your support both for this project but for the training opportunity for our honours, and very excited to see where this may go in the future. So thank you very much, everybody.